Hello friends, myself Aher Dr. from RBNB College Srirampur. Today I deliver a lecture on mechanical properties of solids from 11th Science as per Maharashtra State Board syllabus. Everybody is familiar with solids. Matter are of three types: solids, liquids and gases. Out of those, we know that solids having definite shape and size. One important properties of solid is solid having definite shape and size. If we apply some external force on the solid, then there is change in its shape or size or both. That is called as deformation. Deformation. In case of solid, if we apply some external force, then there is change in its shape and size or both due to an external force. That is called as deformation, and corresponding force is called as deforming force. So for that, if we consider this is spring, if we apply a force on the two ends of the spring, as like this one, there is change in its shape and size. That is called as deformation. That is called as deformation. So we write, what is deformation? The change in a shape or size or both due to an external force that is called as deformation. Now we know that if we apply large force on the two ends of the spring, then deformation is large. If we apply small force, then deformation is small. Therefore, we can say that this deformation depends upon deforming force Deformation is directly proportional to deforming force, and that's why we can say that if applied deforming force is large, then deformation is large. For smaller deforming force, deformation is small. And what is deforming force? The force due to which there is change in its shape and size or both, that force is called as deforming force. Now this deformation is in the form of if we consider the spring, due to deformation, there is change in its length. So, in this case, deformation is in the form of change in length. Also, this deformation is in the form of change in shape and size. or size. So this is about the deformation and deforming force. Now, again when we consider same example, if we apply the force on the two ends of the spring and applied force is removed, then what happens? The spring regains its original dimensions, means it regains original shape and size. Such type of bodies are called as elastic bodies. So in the chapter we have to study about the elastic properties of solids. So first of all, what is the elastic body? The body which regains its original shape or size as soon as applied force is removed. Such body is called as elastic bodies. So remember again, what are the elastic bodies? The bodies which regains its original dimension as soon as applied force is removed. For example, all types of metals, rubber are the examples of elastic bodies. Now, corresponding properties of elastic bodies is called as elasticity. So we define the definition of elasticity. What is elasticity? The property by virtue of which material body regains its original dimensions as soon as applied force is removed. Such property is called as elasticity. Or in other words, we can say that what is elasticity? Elasticity is the property of elastic body. So remember again, what is the definition of elasticity? The property by virtue of which material body regains original dimension, means shape and size, as soon as applied force is removed. Such property is called as elasticity. Now, depending upon that property, we can also define the definition of perfectly elastic body. Perfectly elastic body. The body which regains original dimension as soon as applied force is removed. Such body is called as perfectly black body. But there is no perfectly black body in the nature. There are some ideal perfectly black bodies, ideal elastic bodies like quartz fiber. So this is about the perfectly elastic body. Again, there is another type of body, that is say plastic body. So, plastic body is a body which do not regains original dimensions or shape or size as soon as applied force is removed. There is permanent deformation is there. Such body is called as plastic body. So in simple word, what is plastic body? The body which do not regains original dimension as soon as applied force is removed, and its corresponding property is called as plasticity. Its corresponding property is called as plasticity. So again we define the definition of plasticity. Very simple definition. The property by virtue of which material body do not regains original dimensions as soon as applied force is removed. Such property is called as plasticity. Example of plastic bodies are mud, clay, putty. These are the examples of plastic body. Putty is the ideal plastic body. So this is about the elastic body and plastic body. Now we have to study the elastic nature of solid. If you consider this example of spring, if we applied the force to the both ends of the spring, then length of spring increases. There is another force inside the spring, that is internal restoring force. The magnitude of applied force and internal restoring force is equal, and the internal restoring force per unit area is called stress. So remember again, what is stress? Stress means the internal restoring force per unit area. As you know that this internal restoring force is equal to the applied force. Its magnitude is equal to applied force. Therefore, again we can define stress as like that. Stress is the applied force per unit area. So, with the help of this one, we can write the formula for stress. Stress is equal to internal restoring force upon area. So we get stress is equal to, formula for stress is equal to F upon A, where F is applied force or internal restoring force and A is area of cross section. This stress can be classified in three ways. As you know that deformation is in the form of change in the length, also it is in the form of change in the shape, and also it is in the form of change in the size. Therefore, stress is classified in three ways or types of stress. First type of stress is tensile stress. Second type of stress is volume stress. And third type of stress is shearing stress. There are three types of stress: tensile stress, volume stress, and shearing stress. If we consider deformation is in the form of change in the length, then corresponding stress is called as tensile stress. This tensile stress is also called as longitudinal stress. Also it is called as compressive stress. So in case of tensile stress, remember that when deformation is due to the change in the length, corresponding stress is called as tensile stress or longitudinal stress. Now another type of stress, volume stress. When deformation consists of change in a volume, then corresponding stress is called as volume stress. It is also called as hydraulic stress or hydrostatic volume stress, because this is related with the change in the volume, not in change in the shape. Here only consider we consider only change in the size, means there is change in its volume, therefore this stress is called as volume stress. So remember this volume stress. What is volume stress? When deformation consists of change in volume, then stress is called as volume stress. Last stress, shearing stress. In case of volume stress, there is no change in its shape, only size changes. Shape remains same. In case of shearing stress, there is change in the shape. So such type of stress is called as shearing stress. When deformation consists of change in a shape, then corresponding stress is called as shearing stress. In this way, this stress depends upon deformation, and as we know that deformation is in the form of change in the length, change in the shape, and change in the size. Related to that, there are three types: tensile stress, volume stress, and shearing stress. Now come to this formula stress. Stress is equal to applied force upon area. With this formula, we can find out the SI unit of stress. SI unit of force is Newton. SI unit of area is meter square. So SI unit of stress is Newton per meter square. Also, SI unit of stress is Pascal. Then CGS unit of stress is, CGS unit of force is dyne and CGS unit of area is centimeter square. So CGS unit of stress is dyne per centimeter square. Now dimensions of stress. For finding the dimensions of stress, we know the formula. Stress is equal to force upon area. So dimensions of force are m raised to plus 1, l raised to plus 1, t raised to minus 2. And dimensions of area are only l raised to 2. Now this plus 2 on upward side will become minus 2. Minus 2 plus 1, it is minus 1. So we write m raised to plus 1, l raised to minus 1 and t raised to minus 2. These are the dimensions of stress. In this way, we obtain the dimensions of stress. M raised to plus 1, L raised to minus 1 and T raised to minus 2. This is about the stress. Now we stop here. Thank you.